Welcome everyone. Welcome to stream number 7 we're on now. So today we're going to talk about inheritance. Last week it was classes, so it's kind of carrying on from that. I've turned on subscribers only to the chat, so please make sure you're subscribed if you want to chat, which will hopefully avoid some of the spam we've been getting in the chat recently. So before we talk about inheritance, I just wanted to talk quickly about Rvalue references. Now, I've done a stream on these already, so I'm not going to cover that again. So if you're interested and you haven't seen it, do go back and have a look. But there was a Twitter thread this week where a programmer who I very much respect said he'd been pushing Rvalues for quite a long time to avoid lots of copies for performance reasons. And now he's thinking about not doing that anymore, avoiding them, because he found that on some platforms there were hidden copies happening where they shouldn't be, but technically they're allowed if you look at the small print in the C++ standard, and that's really problematic. If you can't 100% rely on Rvalue references always working, then they're pretty useless, especially if you're doing cross-platform work. And I just thought that was pretty interesting for an experienced programmer like that to say that he's considering not using them anymore. And he also mentioned that it can, I think if I understood correctly, he said it can cause bad habits where people rely on the fact that, I can just copy stuff around because it's all going to be, the copy is going to be made to not happen by our Rvalue references. And if you haven't set it all up correctly on every single thing, then people are going to get into the habit of copying data and just not thinking about it. So they'll just put complex classes in arrays like that, not think about it because, don't worry, our Rvalue references, But if it isn't all set up on every single class, then you run into problems, and it can take quite a long time to set up for every single class. It can be pretty complex. So it's adding an awful lot of complexity, which should magically solve the problem. But if it doesn't magically solve the problem, or does only in 95% of cases, then you're really running into trouble. And I just thought that was pretty interesting that someone is coming to maybe the same conclusion that I am about them, because I don't use them at all. And for example, if I've got an array and contains my object, for example, then if this is just a simple struct, then fair enough. But as soon as it's a more complex class, I just turn it into a pointer. So, and if I want to have if this is important for performance for memory or something, then I'll just create an allocator for them. So I'll have an array of pointers and then an allocator, which keeps it all contiguous in memory, rather than doing that. And then just hoping my incredibly complex array class with Rvalue references everywhere magically somehow gets rid of all the copies. I know it's not going to do anything complex in this case. And I know what my allocator does. It's very, very simple. So that's just something to keep in mind. I mean, I defy anyone to look at my codebase and optimize it by adding Rvalue references, because there are just no copies where they don't need to be. I'm very copy averse, and I know when copies are happening, and I never do them pretty much by mistake or without knowing, because all my classes are so incredibly simple, and I do this everywhere. So my code would probably not benefit at all from adding any Rvalue references. That's pretty interesting, because my code, hopefully as you can see from the 10x editor, it is pretty fast. And I don't believe adding more complexity would solve that. I mean, obviously, if you're working in a legacy code base and it has modern C++ all over the place, then yeah, you may well have to add Rvalue references to optimize it. But if you're coding from scratch, which these kind of streams are more for people who are coding from scratch, writing big code bases themselves, or starting a small project and thinking about how to structure and how to use C++ from the start. And that's what I want to kind of get across. There is another way of doing things than all of the big complex C++ you see in many large projects. And that's something I've, from writing 10x editor, been able to do myself, because I've written pretty much everything from the ground up over the years. And it's allowed me to find out what works, what doesn't, and to use C++ in a very restricted and very simple way. And that allows us, as I've been saying all along, to concentrate more on the problems we're trying to solve than on the language itself. So I don't care about the language at all. I mean, I could have spent some more time on the Rvalue references and shown you exactly why these hidden copies are happening. But to be honest, I thought, why do that? Because I'm just going to say don't do it in the end. And I'm so glad I don't have to worry about this kind of stuff. It's really nice not to have to think about complexities like Rvalue references. So don't add complexity to solve a problem if you can help it at all. Always try and keep things simple. So complex code has problems, and the C++ way of solving that is usually to add more complexity on top. Don't do that. Remove complexity, keep it simple, and don't have side effects. So anyway, that's Rvalue references. Just want to quickly go through that. But I'm mainly going to concentrate on inheritance. And as usual, do ask questions as we go. And I'll be using the 10x codebase, as always, to try and show you real-world examples of what I'm talking about. So if you see something in my code, feel free to ask me about it if you're not sure. That's what these streams are all about. So last week, I just talked about classes, and from a C point of view. And I didn't talk about inheritance at all, but I just talked about the benefits of using classes. Say you were just using plain C and you didn't have classes. Why would you move to using classes? Forgetting all the rest, inheritance and everything. And I just gave a load of examples of why I believe classes make things more tidy, more manageable, and easier to maintain. So even without inheritance, I would still say use classes, just because of all the reasons I listed last week. Because a lot of people think, oh, as soon as you've got classes, you've got inheritance. Well, that's not the case. You can get a lot of benefit from classes without any inheritance at all. And I just wanted to make that point absolutely clear. So classes do not inherently mean inheritance at all. And as you can probably guess, my view on inheritance is to use it as little as possible. So that's the goal. Use the least amount of inheritance possible. Don't reach for it as your first tool to try and fix whatever problem you're fixing. And that's something when people are being taught C++ for the first time is not emphasized enough, in my opinion. They always tell you how to use inheritance and then how to solve every problem imaginable with inheritance. And in the real world, that's usually a recipe for disaster. So use it as a last resort. And when you're using inheritance, obviously keep the hierarchies as flat as possible. That's fairly standard advice, I think. Because deep inheritance hierarchies are problematic. So I remember back in the early days, back in say around 2000, and people were starting to use C++ in the games industry, and we used to create these horrible inheritance hierarchies for game objects and stuff. So we'd have typically something like this. I mean, this is a very basic, silly example, but you kind of get the idea where you have a game object and then maybe you have a driving object because the physics work in a certain way for vehicles with wheels, whatever, going on the ground. And then you have a car and a motorbike inheriting from driving objects. And then similarly, a flying object, you have different physics for flying objects and they zip around. You have plane, rocket inheriting from that. And then the designer comes along and says, what about a flying car? We want to add a flying car to the game. And you go, where does that fit into my hierarchy? I can't inherit from car, I can't inherit from flying object, I really want to inherit from both. And then it just starts to get really complex. And people used to do this kind of thing. You probably think it's silly now because it's not done so much, but we used to, back in the day, it was a real problem. And you would end up with huge hierarchies of game objects, and then the design would change, and suddenly the hierarchy, you realize you need to totally rejig the hierarchy, and you can't do that without refactoring a whole load of code. So the solution to that was the component, what I used to call the component system, what's now called the entity component system in some engines. And I use this for the game I worked on, Sudeki, back in, I think it started around 2000. And it was just around the time where people were talking about component systems and using containment rather than inheritance to structure the game data. So typically you'd have, I mean, I'm sure most of you know what ECSs are now, but just in case you don't, you'd have an entity class and then component-based class, usually virtual, and you'd have a list of components in the entity, and then you might have a, what did I have in my example? So let's say a driving component. And then similarly, flying component, etc. And you can add any of these components to any entity, and you can have multiple components if you want to. And it's so much more flexible, obviously, than a big hierarchy of things. So this is something that you probably are familiar with, the entity component system, but it's a good model for general programming in C++. I'm not saying definitely use this specific system, but I have a general rule that containment is always preferable over inheriting. So another way of putting that is don't ever inherit for functionality only. That's really important. That's kind of my main thing I want to push in this stream. Don't inherit for functionality. So what do I mean by that? Let's look at an example. Try to find the most simple example I could. So I've got what I call a fixed size allocator. Let's make this a bit bigger so you can see. So ignore that. I've got a fixed size allocator, which just basically allocs and frees, standard stuff. And then I've got a templatized version of that. So sorry, 1 second. I want to check something. Good. So one way you might think of doing that is, well, I've got an allocator and I want to add some functionality to it. In this example, templates. So you might think, you want to inherit from that and then just add some stuff and then call into the base class to allocate. Now, I would always say never do that unless you're going to actually use it as the base class. So only ever inherit from a base class if you're going to somewhere in your code use this object as that of the base class. And in this case, I'm never going to do that. I'm never going to use it as a there are no virtuals in this, obviously, because it's an allocator and it needs to be fast. So I'd never put virtuals in there. I'm never going to pass around a general allocator, fixed size allocator. I mean, some of the allocators you might have a base and then a virtual if they're not used in performance critical code. But in this case, this is my fast class. I don't want any complexity here. So I'm never going to use it as a fixed size allocator base class. So I don't inherit. I just use containment instead. So this is a similar concept to the entity component system, where you're using containment instead of inheritance. And this is much more powerful because then if I want, I can inherit something else from this if I really need to inherit. So that's what I mean by never inherit for functionality only, or only ever inherit if you're going to use it as that of the base class. And that's a really strong rule I have. I do break it once or twice, which if we've got time, I'll show you some examples. But in general, that's a rule I always have. So another example actually is this class here. Edit text box list. Now this is, let's show you an example. This is one of these drop-down list boxes. Or up here, we've got another example. So it has a text box where you can actually enter text itself and then a drop-down list, fairly standard stuff. Now, your initial reaction when you're creating this class might be to say, oh, it's kind of like an edit text box, which is just one of these here where you can just enter text. It's like one of those, but it's also got drop down. So I'll inherit from edit text box and then add a list box. And again, that's a bad idea unless you're going to actually use it as an edit text box. And I can't really imagine any case where I would use this as just an edit text box. There might be a case, but in 10x I've never used it. So that it was a good decision not to do that because it keeps the hierarchy flatter. So all of my U objects just inherit from UI object. And pretty much it's a one level deep hierarchy in my UI system. And that's really good, really easy to manage, very nice. So instead what I do is in the members, I've got my edit text box here, and then I've got my list box and a button for the drop down to happen. And so again, list box is just another class which inherits from UI object. So a lot of UI systems you'll see again big hierarchies like this kind of thing, and you end up with similar kinds of problems. But in my UI system, pretty much everywhere I've only got one level deep hierarchy. So everything inherits from UI object, which is a big old class with loads of virtuals in it and lots of commonality, which, as you can imagine, there would be. So anyway, that's another example of where you might be tempted to inherit for functionality. Well, you have to ask yourself, am I just inheriting for functionality, or am I going to actually use this as an edit text box in this case? And in this case, I wasn't ever going to use it as an edit text box. So, I've just used containment instead of inheritance. So again, it's a good rule to have, keeps inheritance hierarchies very flat, really easy to manage, and it just keeps things much simpler. So that's a really good rule to keep in mind whenever you're thinking about inheritance. So we talked about UI object. I could probably talk a bit more about it. There's a lot of stuff in here. For now, I think unless anyone has any questions on that, I think I'll leave UI object for now. So I've talked about ECSs, entity component systems, multiple inheritance. Again, you want to avoid that as much as possible. So I just did a quick search in 10x to see if I've used multiple inheritance. And as you can see, not very much. 5 times. So in my base object class, which I use for upcasting, so it's like a dynamic runtime checked cast. This is the base class for it, and then I have actually inherited from refobj and weak pointer obj. I'll talk about refobj in a minute, and maybe weak object, weak pointer obj, we'll see. But that's, I hardly use this anywhere, to be honest. It's only in the UI system really that I use this object-based class. And it's very simple. It literally just has an array of class types for casting and a type, and that's it. So I'm not inheriting every single thing from an object-based class like some people might. It's only used in a very specific case. And then the other cases are render target, from a render object and an API object. Oh yeah, that was the D3D device resetting. I'm not going to talk about that for now. Okay, here's a good one. So 10x main, the main class for 10x, which is absolutely enormous, as you can see. Inherits from app main, which is app main is my sort of cross-platform app class that applications inherit from. So it's the main application class and manages things like the input manager and creating windows and stuff. But I also inherit from 10x interface, which is probably a good one to talk about. So one area when I will break the rule of multiple inheritance, I try not to multiple inherit, like I said, but if you've got an interface which is pure, an interface is just a class with pure virtuals only and no functionality. So as you can see, every single function pretty much is a pure virtual or a function that just does nothing. So it doesn't have any functionality at all. It's literally just an interface for things that want to implement it. It's pretty big, again, as you can see. Oh yeah, and I added, there's a lot of callbacks that happen in 10x and the UI in general. So for this 10x interface is what I pass around to say, like, some of the stuff in 10x is written as plugins. So I'll pass around 10x interface to plugins so that they can query stuff and modify stuff in 10x and bring up various windows and stuff. So there's a lot of callbacks happening. So in my interface, I've actually got these events which people can subscribe to. So again, there's no functionality here. These are called from within 10x main. So workspace opened event. So when the workspace is being finalized, it'll call this workspace open event on the interface, and then anything that wants to can subscribe to that and get notified. So again, this class is very basic, very simple, big, but it's not doing anything complex. And everything, all the functionality is actually in 10x main. So that's when I might use multiple inheritance, when I've got a nice clean interface like that. I actually like the C# way of doing things where you can actually declare it as an interface, which implicitly makes everything virtual, everything pure virtual. But anyway, we haven't got that in C++, but we can still use the same method of doing it. What else did we have? Fast data grid item, typed objects, refobj. Again, refobj is very simple, just for my reference counted pointers. And again, I just want to be able to upcast these. So that's what this typed object is, which I might show you if we've got time. Let's move on. I think that was the last one. Yeah, it's not very interesting. So, private inheritance. Do I use private inheritance? Again, hardly ever. Because my kind of view is, like I said, you only really inherit if you're going to use it as the type of the base class somewhere. If you're going to pass it around as a base class, then use inheritance. And obviously private stops you doing that. So by my rule, I shouldn't ever use it because I'm not inheriting following those rules. But there is this case in my pointer class. So this is my reference counted pointer class, which you can wrap any object in. I think it's like shared pointer in standard C++. And I do inherit privately. And that's because I use it as a base class in this class only. So if we look for pointer base in this class, this is when I'm assigning one pointer to another pointer and they're different. They're actually different types. So this is a templated, obviously, class, but because you can downcast from one pointer type to another pointer type, I need to be able to get hold of the reference count on the other object, and I can't do that if I'm just working with these templated classes, because it'll be a different template type. So that's why I inherit from pointer base, and pointer base just contains the ref count here. So that's all pointer base is, it's just wrapper around the ref counts. So any, like I said, I only inherit from this in the templated pointer function, because I want to use it internally, but I don't want anyone else to know about the reference count at all, so I don't want anybody messing with it. So that's a case where you might use private, and that's the only cases I've used it, in my ref pointer class and weak pointer class as well, so only in my smart pointers. So let's, have we got time to go into ref pointer, see what else I want to get through. Okay, let's just, before I dive into that, let's go to virtual inheritance. Virtual inheritance I don't think I've used at all in the codebase. If I could type, that would help. Yeah, it's just not there. So nothing uses virtual in 10x, which is nice. Because obviously virtual, as I'm sure you know, is to get around the diamond problem when you have multiple inheritance, two things inheriting from the same thing, and you might get two versions of it, and then it gets really horrible. So virtual just means they'll both be pointing to the same thing. But anyway, I'm sure you know that. But ideally, again, it's one of those things that if you need it, you've probably got bigger problems, and you probably need to rethink your class hierarchy. I mean, there are some cases where you might need it, but in an ideal world, you wouldn't ever need it. So I was just looking through all of my classes in 10x. And that's better. So again, only like 208 matches, and this is in a code base of like 500,000 lines of code. So not that many classes use inheritance. And as you can see, a lot of them are ref obj, just for my ref counter pointer classes. So I've excluded that in this search. So anything with public, but not ref obj, showing here. And do shout if there's anything you'd like me to go into. Just trying to think if there's anything worth talking about here. I mean, the log class is probably a good one to talk about. But again, as you can see, not that much, and not very much multiple inheritance, which is nice. Yeah, ILog is what I've got next to talk about. So let's quickly dive into ILog. Let's move that over. So obviously just a log class with a right line. Actually, that's an implementation. Let's put that over there. So ILog is the base class for it, and it just has right string, virtual, and any other log inherits from that obviously and implements it. And it has some helper functions that any log can use. So I am putting helper functions, I'm putting functionality in the base class here, but in this case it is useful, and I am passing stuff around as an ILog everywhere. So it's fine to put functionality in the base class when you're actually using the base class and passing it around. and then internally they will just call into this. So any log class just needs to implement write string and debug write string. So for example, here we've got the null log class, which doesn't do anything, just writes it out to output debug string. Printf, etc. Function log, where people can subscribe to log messages. So anyway, I've got loads of different log classes. I've got file log somewhere as well, which logs out to a file, and another one which logs out to the output window. So, logging obviously is a really good example of where inheritance is really a really powerful concept. And again, it's not a complex hierarchy, it's just one deep. You just inherit from ILog. So it's a good example of where inheritance should be used and works really well. And you've hardly got any interface tool to implement. It's very simple. So let's talk about ref pointer. So the pointer class I showed you earlier, this class pointer ptr, that's wrapping any objects. So you can ref count any object and it will be obviously deleted on the last ref. But there's one downside of doing that, and that's you get an extra allocation that strictly wouldn't really be needed if you did it a different way. So I don't use this in performance critical code or when I've got a lot of them. If you've got thousands of objects, you don't really want to be using pointer everywhere, because it is going to be creating a new object to do the ref, because you've got to store the ref count somewhere, obviously. So it's got to allocate an object to store that ref count. And a more optimal way of doing that, obviously, is to create a base class. And the base class is actually refobj, and obviously that stores the ref count, and then you inherit your object from refobj. So let's see an example. The file IO system, which again I can talk about in a minute. That's another good example of a nice clean interface, pure virtuals only. So if you want to create a file system, you just inherit from that and implement all of this, and then you can use it on any platform or whatever. So that will help porting 10x to other platforms. Anyway, that's an aside. It inherits from refobj, which means I can have a ref counter pointer to it. So what this is doing, refobj, like I said, is just storing the reference count. So it's stored internally in this class. So this is a case where I am just kind of inheriting from functionality, because I'm never going to use it, pass it around as a refobj, but I do want the reference count in this class. So it just eliminates that extra allocation, obviously, which is good in some cases. So, I mean, it's pretty standard ref pointer class, just think ref, decref, etc. But it's, it's like I said, it's more optimal than using just the straight pointer class than this one. But other than that, it's pretty much the same. So interfaces I think we've covered. Refobj, tuple. Question, do I use the final keyword? No, I don't, but I should. I've just never got around to using it. But yeah, it is very good, because there are cases where when you use final, the compiler can eliminate virtuals, because it knows it can only be a thing of this type and nothing else is going to inherit from this class. So yeah, it's a very good thing to use. It just didn't come early enough in my C++ career for me to get used to doing it. But yes, definitely try and get into the habit of using final if you can. So virtuals, obviously there is a cost to virtuals, and as I think I've said before, the cost used to be quite a lot in the early days on a lot of, say, the console hardwares for games. Virtuals you had to avoid. On modern CPUs, they're much less expensive, but they're still expensive. They're basically as expensive as a function pointer, because the CPU doesn't know where it's going to jump. It's happening at runtime. It doesn't know what type of thing it's got. So when it's compiling it, it can't hard code the address it's going to jump to, and therefore you can't keep the instruction cache warm, and you're probably going to have an instruction cache miss when you do a virtual. So you don't want to be putting virtuals obviously in tight loops. So try and avoid virtuals wherever possible, but they're not as bad as they used to be. When you're overriding things, I have a general rule to always call the base class. So for example, in my UI system, let's think of a good example, text box. Okay, so font change, for example. So this font changed thing is in UI object, the base class for all UI objects, has an on-font changed virtual, which does nothing in a base class. And then you override it if you want to do something when the font has changed, obviously. Now, I have a general rule where I'll always call the base class pretty much, even if, like in this case, it does nothing. Just because it's so easy to forget to do that and get out of the habit of doing that and then miss calling the base functionality when you should do. I mean, there are cases where you don't want to call a base class, obviously, but in my experience, it's always safer to get into the habit of always calling a base class on a virtual function, and unless you really don't want to or need to. But that should be an exception rather than the rule. So that's just a good habit to get into. So I'll quickly talk about Tuple, just because it's one place where I break all my rules in many horrible ways, and I'll try and explain a little bit of why. So the tuple is the same implementation, or similar implementation, I guess, as what's in the standard C STL library or any other library, and it uses the usual tricks of using templates, recursive inherited templates, which is obviously horrible. And it's just horrible that you have to do this kind of thing in C++. It should have a built-in tuple class. I mean, it's crazy that we have to do these workarounds. But this is only a small file. It's just got some horrendous modern C++ template abuse in it. And I'm not going to go through how it works. If you're interested, there are lots of good resources online about how to create a tuple class. But basically, it means you can have a template-sized struct with each member being a different type if you want, and you pass in the types that you want, and it basically creates a struct with members of those types. And it does that by recursion and templates. And it's horrendous, it's horrible. But I don't use it anywhere in my code except for my function class. Let's just check that. So yeah, we can see we've got tuple here, and then my function class, which I think I've talked about a few times, but it's basically for doing callback functions like I showed you in the text interface. So, we've got these functions which people can add. We've got a function list which people can add functions to, which then get called when you call it. And this is a type def of function. So this is a function that takes a string and an array pointer. So to create this function class optimally, you kind of need tuples. And the reason for that is because when you're capturing arguments, because function pointer, this function in class can capture arguments, and that would be called later. So to do that, you kind of need to store them in a efficient way, which is known by the compiler at compile time. So it can just create a struct for those members, assign them, store them off. And the best way of doing that is with a templated tuple class. And the tuple and the function class is pretty much the only place in the codebase where I've done horrible template magic. And I'm not proud of it, but this function class is my workhorse of the UI and 10x itself. It's kind of used absolutely everywhere. And it's really paid off big time. It's really, really nice. And I'll forgive C++ for making me do all these horrible things and workarounds. But that's just one case where I have kind of abused all my rules in general. But like I said, it's one file, quite a big file actually in the case of functions. But the complexity doesn't spread out of this file. There's this file, dragons be in this file. Don't go there or mess with anything. But I'll tolerate horrible language complexity when it's very isolated and won't cause ripples and spread out and infect other bits of code. And that's exactly what this class is. Ideally, I would like a language which supported function pointers to anything, members or globals or whatever, and capturing arguments built into the language. If I was going to write my own language, I would build in a function and a tuple class so that you wouldn't have to write all this stuff. So anyway, I consider the function as part of my language now, and it's incredibly useful. And I never really have to debug it either, which is nice, because I don't want to debug all this template stuff, and I never have to add anything to it. It took me a few weeks to write, I guess, maybe a couple of weeks, to get everything working just as I wanted it, but then I've never had to look at it since. So it's okay, it's manageable, but it's not a thing you'd want to do a lot of. So anyway, I just thought I'd show you because I think it's interesting to see the exceptions to the rules that I'm kind of giving. I'm not giving you rules, but they're rules that I have internally that I kind of mainly stick to until I don't. But there are always exceptions to every rule, and that's fine. That's as it should be. But it's knowing when to make those exceptions. That's what experience, I guess, gives you, knowing what rules to generally have for pretty much everything, and then knowing when it's worth breaking those rules in certain cases. So anyway, I think that's everything covered now, unless anyone has any questions. So that's the general takeaway. I think don't inherit for functionality. Only inherit if you're going to use the object as the base class in some way. And keep your hierarchies flat as possible, usually only one deep. Avoid multiple inheritance, avoid private inheritance, avoid virtual inheritance if possible in general, but there are exceptions which I've covered. And that's about it. And I've tried to give you some examples in my codebase of where I have used inheritance. And interfaces are good, so we like interfaces. You can inherit as many of those as you like, but interfaces mustn't contain functionality. I mean, obviously they can, but in an ideal world, they should just be an interface only with no functionality. So anyway, I hope you've enjoyed that and got something from it. I haven't decided what I'm going to do next week. I've got some notes to talked a bit about smart pointers already in this one, but we could go a bit deeper on that and talk about when to use some templates we could spend a bit more time on. But do let me know if there's anything you'd like me to cover, or you're interested in my opinion on something. I'll see if I can give it and say something useful. But other than that, thanks for watching, and I'll see you again next week.